So 8.2 is all about multiplying, dividing, and simplifying square roots. And then all that happens as we get to 8.3 is they get a little more complex in how we simplify, because we start simplifying multiple terms. Say sure. Sorry, alright. So again, 8.2, all about single terms and simplifying single terms of radicals. Okay, so here's 8.2. Multiplying, dividing, and simplifying radicals. Alright, so there's just going to be a lot of examples. I'll have you remember a couple things from the last section. Mainly, square root of AB is square root of A times square root of B. Square root of A over B is square root of A over square root of B. And you can go either direction with this, right? You can split it up or put it back together. And these, bless you, absolutely work because it's one term. As soon as you say square root of A plus B, that is an absolutely no way, never the square root of A plus the square root of B. Okay, never. Same thing with minus. Thank you. I busted myself. Nice to meet you. Okay, but the reason is this is AB squared is A squared B squared. I was silly guys sometimes. Okay, and AB in parentheses squared is A squared over B squared, but A plus B squared is never A squared plus B squared. I show you this because they're exactly the same. They're both exponents, so they follow all the same rules. Okay. If we have a clump of A times B under a radical, yeah?
Why isn't A plus B squared not A squared plus B squared?
Awesome question. Alright, the reason is A plus B squared is A plus B times itself. And how do we figure out what A plus B times A plus B is? Because that's what A plus B squared is. So let's see, how do we figure that out?
U4.
Oh yeah, we do all that crazy cross, multiply, distribute, A squared plus AB plus AB plus B squared, so A squared plus 2AB plus B squared. So we get that danged middle term. Or visually, the way we can see this is, here's the side of a rectangle that's A plus B long, and here's the side of, no, not a rectangle, a square, that's A plus B long, okay? So let's say some portion is A, okay? Let's say this much is A, this much is B. Alright, well, so the same thing over here. This much is A, and this much is B, okay? So A plus B squared is the area of the whole thing. That's what A plus B squared is. A plus B length times width, A plus B squared, okay? But if we just continue this line, then A squared, this area, plus B squared, this area, misses this whole part. And it misses this whole part, right? So this small square plus this smaller square is not the same thing as the total area, because you're missing this AB area down here and this AB area here. So we need to have those two AB little flaps added in there. So yeah, you can think of it algebraically or visually or geometrically, however you want to use some vocabulary words to think of. But that's awesome. Good question. Good question. So the one new rule we're going to add here is variables. Okay? So how do we take the square root of a variable? Pretty straightforward. The square root of x to the a equals x to the a divided by 2. We just divide the exponent by 2. And we'll say, well, you know, why? Why? Why is that? Why? Think about it this way. X to the 10th squared equals what?
X to the
12? X to the 20?
x to the 20th, you multiply them. So this is x to the 20th, because it's 10 times 2. You could also think of it like x to the 10 times x to the 10. You would add them together and you would get 20. Okay? So since x to the 10 squared equals x to the 20, then what's the square root of x to the 20th?
X to the 10.
Yeah, because we're saying what number, what variable, what thing squared is equal to x to the 20th? Well, that's x to the 10. And again, how did we get there? Is we got from here to here by dividing, whoops, that's not division, dividing by 2. Alright, so we divide the exponent by 2. Let's just really quick bring up a little common mistake. Really common, right? Square root of x to the 16th is
X to the 8.
should be x to the 8. Ooh, but what
X
do
to the
people
4.
say?
X to the 4.
Yeah, classic. So it should be x to the 8, not x to the 4, right? That's important, okay? We divide the exponent by 2. Now you can think about it because, check, what's x to the 8 squared? X to the 8 times x to the 8 is, add them together, x to 16. Or x to the 8 squared is x to the 8 times 2, 16. So it works, right? X to the 4 squared is only x to the 8, not what? Okay. Alright, enough of that. So, let's just do a bunch of examples now, okay? So that's the main first part, is how to deal with variables. Okay, the big second part to this, we're only going to add one little piece of notes to this, and then it's just going to be doing lots of examples, because this is one of those things that's so basic. We're adding one new rule, but there's so many ways in your head that loopholes in this leaky bucket with water spraying out everywhere, and you need to patch every one of those holes by actually doing a bunch of problems. So I can't just sit here and talk and talk and talk. So I'm going to do a couple examples. Add one more thing, pretty big thing, okay? And then we're gonna do some more examples. All right, so, example really quick. Whoa, I have to go pretty far for those examples. Okay, I'll add one more thing first. Okay, so some general steps. And then we'll do a bunch of examples. And I'm going to add to the side here, this is for only one term. Okay, there's a different plan when it's more than one term. Okay, it's just a 3-step process. Step 1. So combine everything into one big radical, one big expression under one radical sign, and then simplify any fraction. Okay, so I'll write an example over here. I'm going pretty deep down in this section. So I'm going to start with 62. Okay, so 62 is square root of 2x squared times square root of 10x. Okay. So, what will we do first? How? Yeah. Exactly. We just write this as one clump of 2x squared times 10x, and then 2 times 10, like you just said, Jess, is 20, and x squared times x is? X to the third. There we go. So here is step 1. Okay, got it. We make it into one clump. Step 2. easily split, okay. Okay, and this is where the like kind of art form and the practice and the comfortable with numbers and variables comes in. Is we need to split this into perfect squares times leftovers. So I'm going to split this into one radical times another radical, and I'm specifically moving all of my perfect squares to one side and all of my leftovers to the other. Okay, for numbers this is easy. Look for factors of 4, 9, 16, 25, 36, 49, etc., etc. You know the perfect squares. If not, get used to it, memorize and learn it. And for variables, what's a perfect square? This is a good question. That's a good question.
Even numbers?
Yeah, but it'd be a little more clear what you mean by even numbers, right?
Or when the variable is raised with an even number.
Yeah, whenever you have an even exponent. So, all right. So in general, the only possible leftovers for variables are no variables or to the 1 power. Okay? Because obviously you can't be to the 2 power because that's a perfect square. You can't be to the 3rd power because there's an x squared in there. Alright? So let's separate this. Numerically, out of 20, how could we split that into perfect squares and leftovers? Right, we only need to check 4, does it go into it? Yeah. Does 9, because we keep going, we see if there's more. 9 doesn't, 16 doesn't, 25 we're too big. So we're done. Okay, so we split this into 4 and 5. Because 4 times 5 is still 20. We're just splitting it into 2 factors. And then, in terms of the x's, how will we split it?
X squared and x.
Exactly. Now, if this was x to the 11, how would we split it? You don't need to write this down, but how would we split it?
10 and 1.
Exactly. X to the 10th is all the perfect squares, and x to the 1 is left over. Okay, that's totally separate. I just wanted to show you that. But all right, so here we go. This is step 2. These are the perfect squares. And these are the sloppy leftovers. Alright, and the third one is just simplify the perfect square radical. Right, so there's no more radical. And leave the leftovers as is. Alright? So, step 3, what are we left with then? What's the square root of 4? And what's the square root of x squared? X. So this first part becomes 2x, and we just leave the square root of 5x as is. Okay, so that's how we simplify one term of a radical. Okay, yeah.
Would it be a mistake if we included the multiplication sign?
Oh, no, if you put a dot in there, totally okay, yeah. Yeah, it's implied, so you can have it or you can leave it out, it's up to you. Right, and then it's just a bunch of examples now, okay? So let's start with a bunch of easy ones, okay? Something like 2, 8. The instructions for all of these are just simplify. 6, 12. So square root of 2 times square root of 17. Square root of 3/5 times square root of 5/7. This is square root of 10 times square root of 10. This is square root of 1/7 times square root of 1/7. Okay, let's do these ones together. And we'll do a few more together. And then I'll just put like 10 plus problems up on the board and you guys come up and do them. Alright, so the first one, what can we do first? Yeah, so what do we get? Yeah, so I'm gonna write it like this first. I know you don't need to do that. But then square root of 34, perfect. And we're done. I know that because that number was exactly made of a 2 and a 17, which are the prime factors. There's no other perfect squares. But we can check. Does 4 go in? No. Does 9? No. 16? No. 25? No. 36? We're too big. We only have to check 5 things. We're 100% sure. It's done. We use a calculator. 34 divided by 4. Nope, it's a decimal. 34 divided by 25. Nope, it's a decimal. Alright? So, for 6, what do we get? Oh no, I was doing 6 first. I know, I wrote it in weird order.
Oh, 100.
Yeah, so square root of 100,
10.
which is 10. Or yeah, square root is this way. Yeah. So, just something to keep in mind, if you ever multiply a square root by itself, the square root cancels out. Because again, as I mentioned, the square root by definition is saying, what number, if I multiply it by itself, is equal to 10. And then if you go ahead and multiply that thing by itself, you should get exactly 10. That's what the square root is saying. What number? It's going to be a crazy decimal, but if I multiply that crazy decimal times itself, I'll get exactly 10. And then if you actually do multiply it, it'll always cancel and you'll get that 10. But you can show the steps. Square root of 10 times square root of 10 is square root of 100 is 10. So, just something to keep in mind. Alright, 8, what do you do? Yeah.
You cross cancel?
Not yet, but in one step you can, yeah?
Combine them?
Yeah, let's combine them into one radical. 3/5 times 5/7, and then?
Cancel out the 5?
So yeah, what do we get?
3 sevens?
Yeah, well,
Square root of 3 sevens?
square root of 3/7, exactly, perfect. Okay, 3 and 7 are prime, so you can't factor anything out. What about 12?
Combine them.
Yeah, well, let's combine them, what do we get?
Whatever to the pay, times whatever's on the B.
Yeah, okay, and how can we combine those a little bit?
Combine the 1 7.
Multiply.
2 7 squared?
Yeah, 1/7 squared is?
Can you just
One, one, four.
multiply the,
Mhm.
multiply like the 1 7 times 1 7 and combine the A and B?
Yeah, so you
1/14 AB.
Yeah.
ooh, not over 14.
49.
Yeah. So 1/49
A, B.
AB, or similarly, you could write it as square root of AB over 4, either one, absolutely the same. Okay, now I would split it up. Okay? What's my perfect square portion of this? Yeah, split it up into 1/49, which is perfect, and, whoops, times AB, which is not. What's the square root of 1/49? Yeah, 1/7, so I'm gonna write it up higher, but yeah, you get 1/7 square root of AB. Or, if you were over on this other side, you would just split it up to square root of AB on top, square root of 49 on the bottom. Square root of 49 is 7.
So then it would be square root of AB over 7.
Yeah, exactly. So if we did it this way and had square root of AB over 49, we could split it up to be square root of AB over square root of 49, which is square root of AB over 7. And that's the same thing as saying like 1/2 x equals x over 2. You could write it either way. So 1/7 square root of AB is the same thing as square root of AB over 7. It doesn't matter whether you pull the fraction out front, that coefficient out front or not. Okay. Alright, so more in general, these problems I'm going to show you right now are what you're going to see a lot of as we do this section and as we do the next section. And as I sadly said, we had to lose 2 sections of chapter 8 due to time. Very sad about that. So, anyways, as we do this section and the next section, what you'll see a lot of are problems like this. 16. So simplify square root of 27. Or 18. Square root of 28. Whoops. Or 28. Square root of z squared. Or 24. Square root of 25x, or last one we'll do together, 36 square root of x to 30. So we'll do these ones together and I'll write up a bunch of examples for you guys to do. Okay? So how could we simplify square root of 27? This is really, really common. That you'll see exactly this number. Yeah, Victoria?
Is it the square root of 9 times the square root of 30?
Yeah. And then which that becomes?
3 times the square root of 3.
Exactly. Boom. That's simplified. Awesome. Okay, the reason we do this is the very next section, which we'll be doing in about half hour, will be something like square root of 27 plus, let's say, square root of 12, which after we simplify will be 2 root 3 plus 3 root 3, and then we'd say, oh, these are like terms. Right, up here we can't combine anything, but down here, 3 square root of 3's plus 2 square root of 3's is
5 root 3.
5 root 3, right? And that's the reason we simplify. It's the same reason that section that got deleted, 8.4, is all about rationalizing the denominator. Again, it's so that we can simplify it and get these like terms and combine as much as we can. So we're not leaving an answer with 5 terms, when actually they're all like terms and can be simplified down, okay? Anyways, that's for next section. So what about 28? So, so let's check. Well, let's see. Divided by the first square root is, the first perfect square is 4. Hey, it's divisible by 4. Check 9, nope. Check 16, nope. Check 25, nope. 36 is too big. So, 4 is the perfect square, 7 is the leftover, right? So square root of 4 is 2, and then we're left over the root 7. Okay, and I would always write this step. I would not skip that step. Skipping that step is just multiplying your number of mistakes by 10 or 100. Okay, so write that. And I would always write the perfect squares first, because if you write it the other way, what ends up happening is if I write square root of 2 times 8, right, and this square root ends, this is 8 root 2, right? We would always write the non-square root thing first, not because it's different. Square root of 2 times 8 is the same thing as 8 times square root of 2. However, this leads to very few mistakes. What do you think people so often do with this?
Multiply 2
And say it's,
square root of 16.
yeah, which is
4.
yeah, but it's not. It's 8 square root of 2, which is a crazy, weird, irrational decimal. So don't write the square root first, and that's why I say don't write the square root of 7 first, because then you'll get the square root of the 7 times 2, which is right, but depending on how you write it, I mean, if you're like square root of 7 times 2, I'm like, yeah, that's under the line, points off, right? And then it'll lead to mistakes as you move further in your problems. So always write the perfect squares first, so in the next step, the 2 is in front. Okay. Anyways, square root of z squared is?
See?
Just z. Divide this by 2 and you get z to the 1, which is just z. Okay? What about 25x?
5 square root of x.
Do say it again?
5 square root of x.
Yeah, but I don't know how you got there. It's a mystery. So Michelle, help me out.
Greatest selfish square root of 25, which should be 5,
Yeah?
and bring down the x as a leftover.
Yeah. And so you get?
5 square root of x.
Nice. There you go. Okay, and after you take the square root of 25, the square root sign's not there anymore. It's like punching the square root button on your calculator. Once you do that action, you have 5, but the square root sign's gone. A common mistake is people do square root of 25 is square root of 5. That's not true. Square root of 25 is equal to 5. Square root of 5 is like 2.1. Okay, so totally different. So once you do the square root sign's not there anymore. Okay? And then 36, last one we'll do together, and then I'm going to write a bunch of examples on the board. So,
Square root of x to the
Jody, you said it a little x to the 15, and why is that? Exactly. Square root of that divides it by 2, so you just get x to the 15. Perfect. Okay? So now I'm going to write up a bunch of examples. I want you guys to kind of do it. The examples I'm giving you are much harder than these easy ones I did for you. Okay. Let's start with 38. So you can be doing these on your paper and then come up and do them. And I say this because, and I'll say it over and over, the reason is the more engaged you get, the more you actually get your hands on this, the more you actually make some mistakes and learn from them, the more of those leaky holes in your bucket you patch up, and the better you are for the upcoming tests. And the awesome part too is people will make mistakes up here, and then we get to talk about these rich, full, colorful mistakes. Otherwise, you're just hearing me, Mr. Perfect Math Guy, who's done all this, being like, some people commonly make this error. And that's so different than having a real person come up who's actually struggling and say, yeah, here it is. Like, I put my heart and soul into this, and I think this is it. And then we have an awesome discussion about, why did you think that? What happens? And so anyways, it's a lot better to have those natural, organic mistakes, right? None of those pesticides in our mistakes. Okay, let's see. Okay, so a ton of awesome examples. Rich, rich ground for making mistakes. Alright. This is really good stuff. Okay, so there's 2 more that didn't get done. But yeah, let's start at the beginning. So this one worked out perfectly. Square root of 36 is 6. Square root of y to the 10th is y to the 5th. Awesome. This one split up into 2 nice even parts. 2 root 6. The only thing I would say about this, it's not wrong, but the only thing I would say about this is How could it be just a little better?
To add the x to the 8th power and square root of that,
But we did that, and we got x to the 4th.
showing the work for it.
Yeah, I mean, showing the work for it would be nice. I would show the work over here because,
Also separate it out, with the x's on each one.
not each one,
On
because
one, on one.
it's just a perfect square.
Yeah.
So that you
Because
need,
it would be you want to put all the perfect squares first,
yeah,
and then the leftovers second.
yeah, so that we don't,
Run
You don't
into
run
any
into that.
problems.
Yeah, no, I did that on purpose so you could demonstrate.
good, but I mean, it's totally correct. I would just always write 2x to the 4th first, square root of 6 last, that way this square root sign isn't there.
With the x squares.
Another way to get around that is you could put a little dash down. Your square root could look like that. Just add ending here instead of like just slash. But either way, that's correct, 100%, perfect. Alright, so we did one baby step. We did like one step out of like 3 steps. Okay? So that's good. Yes, you can take out a 4, correct, but
Didn't take out the y to the 100.
ooh, we'll get there first, but even we're not even done with the numbers yet.
I didn't put the perfect squares first and the leftovers second.
But we're still not even done with the numbers yet. We did separate it.
We're not done with the numbers? We didn't put the 8 over the square and the square?
Nice. Eight's
Can
in the square.
you keep going with the y,
We'll keep going with the numbers first.
the numbers?
So the y, right?
How many got the y's? Let's get to the y's in a minute. First, we still gotta deal with these numbers.
Okay, so what's 8 squared? No?
Break down the 8 to a 2 and 4.
Oh, there's another 4 in there.
There you
You
go.
can
So-
break down that?
Yeah, well, so one way to think of it is at the beginning, you could have gone with a 16 times 2. Or you could have split this into 4 and said, hey, there's another 4. And there's a square root of 2. Or you could even make it to here and say, hey, I'm gonna split it up here. Right? And then get 2 times square root of 2. Or up here, 4 root of 2. So okay, in terms of numbers, I've got 4 root of 2. And then in terms of variables, what were the perfect squares?
Can you keep going with that?
What was the, like, how many of these come out perfectly?
10.
Why did
So, I mean, you were right that all of these come out perfectly, because it's an even number. And you're right that the result is,
50.
no, y to the 100. It's right, except,
it's not outside?
yeah,
Um,
you already did the square root. You don't need to do it again,
Yeah.
mm,
right? So you're done with that. So the y to the 100 is now out of the square root, but again,
You could
I
put
would
it all front.
always put it in front, so it'd be 4y to the 100 left over with square root 2. Okay, so you can absolutely break it down in step after step after step, or if at the beginning you're careful, it's like pulling out the greatest common factor. You could do it in steps, like a 2 comes out. Oh, and a 3. Or you could do it in one step. Alright, the next one, I would just write a second square root there, but yeah, perfect squares, non-perfect squares. Square root of the even ones are y, square root of the non-even ones stays there, and your answer is y squared root of y, perfect. 52, we split it into perfect squares and non-perfect squares. I'm confused by this last step, but the first step, we would split it into square root of 4 and square root of 3. Great. And they did square root of 4 is 2. Okay, so skip the step but got there. Okay, so 2 and but not 6. Right? Because so that's there somebody skipped a step here. So I would split it into the perfect squares, which is 4 and 3, and yeah, square root of 4 is 2. But what's left over in here is a 3 now. Because it's not splitting it into 2 and 6, because neither of those is a perfect square. We're only trying to pull out perfect squares. Okay? But in terms of the variable, we
yeah.
can pull out out some of the x to the 7s.
So you do like 6, separate like 6 and 1, or 4
Exactly.
Yeah,
All of the even ones
4 and
come out.
3.
Exactly. You could do 4 and 3, you could do 2 and 5, but the most is
6 and 1.
6. Alright, and we're left over with just 1. Okay, so we don't just leave that x to the 7 behind. I think I saw that in another problem too. So we get square root of 4 is 2, square root of x to the 6th is x to the 3rd, and then times that sloppy 3x that's left over. Okay, over here, multiply them together first, and then both of those are a perfect square. Just 10x, awesome. Okay, 64, first multiply them all together, perfect, then split it up. So in terms of numbers, we are one step towards there, but there's even more, right? What perfect square is still hiding and lurking inside 8?
4.
Another 4. So back at the beginning, there was something bigger. There was a 25 times a 4. What's 25 times 4?
100.
There was 100 in there, right? Square root of 100 is 10. So we could have split this at the beginning to be right here. We could have said this is square root of, and pulled out the whole 100 and just left a 2 there. However, you could do it later on, down here. You could still split it to be 5 times square root of 4 times square root of 2. So it doesn't matter whether you do it at the beginning or whether you realize later on. Okay, it doesn't matter when it happens, but you do need to pull out every perfect square so get really comfortable with those. Yeah.
Would you leave all the square roots there? Like 5 times square root 4 times square root 2?
No, you would just be part of the process. So then you would say, this is 5 times, the whole reason we did that was the perfect square 4 is 2 times square root 2, or 10 times square root 2. So the whole reason we separated it, so the perfect squares, the square root goes away. And then we get as much as we can out of the square root. Okay? And then the variable, same thing as over here, we can pull some out, right Jess? How many of those 13 could we pull out?
12.
Exactly. We can pull out all of the even ones, and so the most evens that we can pull out is 12. So we would have done x to the 12, and then you have 1 left over. So here, numerically, we did get this out, and I would give partial credit, this is 100% equal to this, and it is simpler, but it's not all the way simplified, right? Of this, there was still a 4 lurking in there, and then here there was an x to the 12. So there were still perfect squares in the numbers and there. So you just have to go further and further. So now, what's the square root of 100? And square root x to the 6? Or x to the 12? Oh, I like to give away surprises. Okay. And then 70, yeah, question?
Would you mark us off points if we forgot to write down the variables?
Yeah, for sure. If I say, go completely to the finish line and you take 1 step and say, are you gonna take me off points because I didn't make it there? No, for sure. I'm gonna say, yeah, you didn't make it to the finish line. Okay, so this, yeah, would just be square root of 100 over square root of 9 or 10 over 3. Perfect. Okay, this one down here, there's 2 different approaches, right? This person chose one approach. They separated the perfect squares. They got 5 root 3 over root 3 and then said, hey, these cancel. That's equal to 5. Awesome. What else could you have done at the beginning?
Divide everything by 3?
Yeah, you could have just written this as square root of 75 divided by 3, or square root of 25, or 5. 2 different approaches, absolutely both perfect and awesome. Okay? So, 78, right? There's nothing that cancels, there's no simplifying. So let's just take out the perfect squares. Okay, maybe it'll help if we write this as square root of 300 over square root of y to the 30 and simplify each one separate. Okay, so Ruthie, on top, what perfect square goes into 300? Give me a hint, it's a nice pretty one. So no fault, so it's, guys, this is why I'm saying memorize those common powers so that those 10 or 15 common exponents come up second nature. Because when you look at that, it should jump out at you that what perfect square is in there? 100. Right away, if you see something that ends in 0, 0, you know you're pulling out 100. If you see something that ends in 25, 50, or 75, what are you thinking you're pulling out? Yeah, well, pulling out 25, which will then become 5, yeah. Okay, so those are those perfect squares that you just readily identify, as in, I'm gonna take that out. Okay, so this one, yeah, top, we're gonna split the top one into square root of 100 times O left over 3. I think there's a song, was it in Harold and Kumar, where it's like, I'm a square root of 2 or I'm a square root of 3. It's a great song. It's like, I'm irrational without my partner, my 1 square root of 3.
That poem that he wrote for his thesis paper or something.
Yeah, and then he read it in like the wedding that they crashed at the end of the movie. Oh, it was a great poem. I posted it on my classroom wall and
Which Harold Kumar movie is that?
There's a second.
I have no idea.
There's a second at the very end.
I was gonna say, there's at least like 4 of those
Yeah,
movies.
that's something like that.
Yeah, I think about half of the first one was awesome, and then it just, but I really like that poem, I really liked it. Okay, what's the square root of y to the 30th? Just y to the 15th, right there. And so this was just 10, so it's 10 root 3 over y to the 15th. And then last one, what's the first step? That's the killer in this one, what's the first step? Right, we have a 3-step process in this section, what's the first step? Yeah, because it's the same as 60, 64, and 80. First step is? But, I mean, a little more clear, you're right, it's divide. But how do we divide?
By the 2 x on top.
But I mean, what do we have to do before we divide?
Oh, wait.
Combine them into one fused together square root. And then, yeah, it's a fraction. Then you can divide whatever you want. As soon as you write it as a fraction like this, oh yeah, normal of fraction, you can just cancel, reduce whatever you want. Okay, so this is 200 x to the 3rd under a square root, and now it's not even a fraction anymore. So that's what you do first. First, combine it into one mess and simplify if you can. And then I'm just gonna bring it up here so we have a tiny bit more room. But what perfect square goes into 200x to the 3rd?
100 times 2.
100 times 2. And what variables are perfect squares?
X to the 4.
X to the 4th, it's only x to the 3rd.
Oh.
Yeah, because we simplified it. So yeah, just the x squared with a leftover of x. So it becomes 10x root 2x. Okay? If you simplify the top, what you would have gotten is, you would have gotten 20x squared over this, and then you would have had to rationalize the denominator, which is section 8.4 that we're sadly cutting out. And so you would have been stuck. So definitely combine things first and simplify after you've got one clump, one set of terms. Alright, we'll take a little 10-minute break, then when we come back, we'll do the next section. There's not that much new, basically combining like terms and doing some like FOIL, distributing crazy multiplication of polynomials, and then simplify. Oh, time to go lie in the sun again.